Okay, team, let's take a look at the in-class assignment for design storms. Please submit a single PDF of this assignment with screenshots and whatnot, graphs, etc. The first thing we're going to do is create a hydrograph based on the temporal distribution data for NOAA 14, the atlas. And the first thing we'll do is navigate to the website, click on that link, and it's going to bring us to NOAA's website, the precipitation frequency data server. We can click on Colorado, and then that'll bring up a map. And what this allows us to do is really click on anywhere in Colorado, and it'll give us the precipitation depth at a given frequency and duration. You can actually select a station if you want to. So these are weather stations and actually get the point data, or you can really click anywhere, and that's where they extrapolate the data out using some statistical analysis to at any point in the state. So we'll just search Denver, Colorado. You can do this for anything you want, any place you want in Colorado, but I'm choosing Denver. And you'll see that we've got this table populated with duration of the rainfall events, the average occurrence interval in years, and then the depth. Note that we also have a confidence interval in there. So I'm interested for this assignment in the 10-year, 6-hour duration storm, so that's 1.94 inches. Now the next step is to get the temporal distribution. So these temporal distributions are based on storms. And you'll see that I've got the 6 all the way to the 96-hour storm event. So what they did is they took these windows of time at these rain gauges and looked at how the distribution of rainfall occurred temporally. Did a lot fall up front, in the middle, or at the end? And then they rank those storms by by how early or how late the rainfall fell. So we're going to go for the 6-hour duration one, submit. And this is going to give me a CSV file. I'll open that up. And what you see is then this information. This is for Midwestern Region 3, so that incorporates Colorado. So again, these are regional distributions based on regional data. And I see then I've got my hours, my time in hours and 50-minute intervals or half-hour intervals. And then I've got the percent of occurrence, and this is percent of rainfall occurring either early on or later. And I've made a plot here that is based on quartiles. So that's quartiles just 25%, 50%, 75%, et cetera. So what we'll do with this data is, I'm going to kind of go over to a new Excel document, is we'll plot. We're going to look at 2 different storm events. We're going to look at the 10% event, and that's actually on this side, that says that 10% of the storms had rainfall falling kind of at the earliest side of things. So they kind of said, okay, what's the, within the first 2 hours or so, what percentage of storms had most of the rainfall fall early on? And so that's what this 10% is. And so I've just plotted it. I have time on the x-axis and cumulative percent rainfall on the y-axis. And then I'm also looking at the median rainfall events. So this is kind of middle of the road. So for this temporal distribution, all we're doing is we're going to convert this temporal distribution to a hydrograph. And so that's what we're going to do here. Let's look at first just the cumulative percent. And all I do is I have the time, the x, and then I'm just going to copy over my cumulative percent, so 50% and 10%, and bring those over here. Now I'm going to do incremental precipitation, and I am keeping this as percent, and so this is just going to be the difference, right? So between each time interval, how much what percentage of rainfall fell? All right, so I'm just subtracting these, and 30% fell in the first half hour, in the second half hour, 28%, and so on, right? And so I did that for the 2 different storm events. And then now I scale it. So for Denver, I said 1.94 is the rainfall depth. That fell over 6 hours. And so all I do is I take that rainfall depth which is right here, 1.94. I lock it in with those dollar signs. And then I say, okay, multiply it by the percent divided by 100, right? Because we want to ultimately get a fraction. So I do that, and then I get the incremental depth in inches based on that percent and the total depth. And then I sum it up. Make sure it's 1.94. I do that for the 2 storms. And then I get my hydrograph. I give you some directions about how to create this plot. These kind of overlapping or stacked bar plots are a little challenging. So make sure you read the information on that, 2D, clustered column, etc. And then you'll create a plot that looks like this, where you have the 10% storm, meaning 10% of storms had rainfall that fell earlier. And then here's that median storm event. So these are hydrographs or hydrographs with plots at every half hour or 0.5 hours.